All right. Let's see how we do on the warm-up today. First thing they want us to find is segment AB. This segment right here. How big would that segment be? 6.9. Yes, there's a congruence mark on AB. There's the same congruence mark on BC, so that means they would be the same size. Then they also want us to find the measure of angle BDA. So B down to D, and then up to A. So we're looking for this angle right here. How big is angle BDA? 30 degrees, absolutely correct. That long diagonal cuts the two opposite angles into in half, cuts it into two congruent parts. So the measurement of angle BDA is exactly the same as BDC, and they tell us that BDC is 30 degrees, so BDA would have to match and also be 30 degrees. Moving over to our second kite in number 4, what would the measurement of segment EH be? 3.7, absolutely correct. We have congruence marks on EH and GH, so EH is the same measurement. And then the last thing they ask us to find is the measurement of angle EJF. So E to J, J to F. So we are looking for this angle right here. How big is that angle? 90 degrees. The diagonals of a kite are perpendicular to each other, so it forms 4 right angles right there where they cross. So the measurement of angle EJF is 90 degrees. Very nice work on the warm-up today, guys. The rest of our time together, from now until the end of C lunch, I will answer any questions you guys have off of the test review. If you want to go ahead and pull the test review out and start looking through it. Yes, ma'am. Number 10, absolutely. Let's go look at number 10 first. Number 10 says, given the diagonals of a rhombus are 16 meters and 30 meters long, what is the perimeter of the rhombus? So I need to draw my shape here. I need to draw a rhombus first. What do we know about a rhombus? Specifically, what do we know about the sides of a rhombus? Because I need to draw one here. Yes, 4 equal sides. I know that one of these diagonals is much longer than the other. So I know it's not going to be very square looking. All right, so here's my rhombus, or at least my best attempt at a rhombus. And then I'm going to draw in the diagonals. So connecting my opposite corners, I'm going to connect top to bottom, and I'm going to connect left to right. It tells me that the shorter diagonal is 16 meters, and the longer diagonal is 30 meters. Let's look at this shorter diagonal. This whole thing right here is 16 meters long. How big would each segment of it be? Yes. 8, absolutely correct. These are congruent to each other. And so each section would be 8, because 8 plus 8 gives me 16. What about that longer diagonal? It said the whole thing is 30. Yes, ma'am. 15 and 15, absolutely correct. Because it's a rhombus, I should come in here and mark the 4 sides of my shape as congruent to each other. I don't know how big they are. In a rhombus, the diagonals don't just bisect each other. What's happening right here where they cut each other in half? 4 90-degree angles. So we are supposed to find the perimeter of this shape. If I can find the length of one side, then I know the length of all the other sides. And that would allow me to find the perimeter. So I'm going to look at just one of these little triangles here. Because it's what type of triangle? It's a right triangle. And what can I use to find missing sides in right triangles? Yes, we can use the Pythagorean theorem. A squared plus b squared equals c squared. When I'm looking for the side of the rhombus, would that go in for A, B, or C? C. It's across from the right angle. So the piece that we're looking for is the hypotenuse. I don't have a name for this hypotenuse, so I'm just going to let it stay C. And I'll know that that answer goes on the side of my rhombus here. But the 8 and the 15 would go in for A and B. It doesn't matter which one you put the 8 in for and which one you put the 15 in for. So we're going to have 8 squared plus 15 squared equals C squared. Well, I know 8 squared, that's 64. What's 15 squared? 225. And what do I get when I add those two together? 289 is equal to C squared. And then we do what? Square root it. If you do it to one side, you got to do it to the other side. The whole reason we're square rooting is so that we can get rid of this squared that's on the C. And what is the square root of 289? 17. So C is 17, which is not my final answer, but I needed that. This is 17 meters. That means this side over here is also 17 meters. Down here is 17 meters. And over here is 17 meters. Now we're going to find the perimeter of this shape. What do we need to do to find the perimeter? 17 times 4, or we add 17 4 times. Either way, you should end up with the exact same answer. So we do 4 times 17. And what is 4 times 17? 68. So the perimeter is 68. And we do need units on that. What kind of units should we put? Meters. Wonderful work there. What else would you guys like to see? Number 4? Absolutely. Find the measure of each interior and exterior angle of the following regular polygons. So the only reason we are able to do this at all is because these are regular polygons. To find the measurement for an interior angle, we do n minus 2 times 180. That gives me the sum of all the interior angles. And then if I want just one, I divide it by the number of sides I have. And this only works, again, only works because it is regular polygon. If it's not a regular polygon, I cannot use this formula. How many sides does a decagon have? 10 sides. So that's what I'm going to put in for n. So I would have 10 minus 2 times 180 degrees divided by 10. 10 minus 2 is 8. What is 8 times 180? 1,440 degrees over 10. And 1440 divided by 10 is 144. So 144 degrees for the measure of one interior angle. For our exterior angles, the numerator is always the same. It's always 360 degrees divided by n. Yep, it's 10 for this one. You're absolutely correct. So we do 360 degrees divided by 10. What is 360 divided by 10? 36. Does anybody remember what we said about the interior and the exterior angle if I have one of each? What should they always add up to? 180. So let's check. Interior angle plus exterior angle should equal 180. 144 plus 36 equals 180, so we are good. It also means that if you can find either the exterior or the interior, if you can only find one of them, you could minus it from 180 to find the other one. So if you don't remember the formula, but you do remember how to find the exterior, 360 divided by your sides, you can minus that from 180 to get your interior. All right, part B. How many sides does a heptagon have? 7 sides. 8 sides is an octagon. 7 sides for a heptagon. So for my interior angle, we do n minus 2. So 7 minus 2 times 180 divided by the number of sides, so divided by 7. Well, I know 7 minus 2 is 5, so in that numerator I have 5 times 180 over 7. What is 5 times 180? So 900 degrees divided by 7. This one does not come out to be a whole number, but that's okay. It's about 128.571 degrees. Yep. And then for that exterior angle, 360 degrees divided by the number of sides, which in this case is 7. What is 360 divided by 7? Yep, 51.429 degrees. And again, we can check that. 128.571 degrees plus 51.429 degrees. Does that come out to be 180? Yes, it does. 180 degrees. Now, depending on how you round, for ones that don't come out to be nice, whole, pretty numbers, depending on how you round on your calculator, you might end up with like 179.999 because of the way you rounded. If you have to round an answer, if they don't come out to whole numbers, and that's what you get when you add them together, that's okay. That would just be a little rounding error there, but I'm not going to take off points for anything like that. What else would you guys like to see? 6, 13, 5. Did I hear 13 correctly? Okay, so we'll do 6, 13, and then 5. Number 6, parts A and B. Awesome, okay. So A, B, C, D is a kite. They didn't do a very good job of getting it back in the corner, but this 16 degrees is this angle right here. We're supposed to find the measurement of angle 1, angle 2, and angle 3. What is that long diagonal doing to my opposite angles? What is this long diagonal doing? It's bisecting. It's bisecting angle A and angle C. Now, angle A and angle C aren't congruent to each other. But if this little bit here is 16 degrees, how big is angle 1? 16 degrees. Angle 2 is happening right where these diagonals are crossing each other. What kind of angles are there where those diagonals cross? Right angles. So how big is angle 2? 90 degrees. To find angle 3, I'm going to have to use the fact that this is a right triangle, or more specifically, just that it is a triangle right here. I know how big 2 of the angles are. One of them is 90, the other one is 16. So what could I do to figure out the size of angle 3? Absolutely correct. 90 degrees plus 16 degrees plus the measurement of angle 3 equals 180 degrees. What do I get when I add the 90 and the 16 together? 106. So 106 degrees plus the measurement of angle 3 equals 180. And then I subtract 106 from both sides, and we get 74. Absolutely correct. So measurement of angle 3 is 74 degrees. Right, then we get to part B. And in part B, do we have a kite? What do we have? A rhombus. What do we know about the four sides of a rhombus? They're equal. So all my sides are 20 because MD, this side right here, is 20. What's happening right here with my diagonals? Bisecting and 90 degrees. You guys are both right. So that means this little segment here is congruent to this little segment. This little segment is congruent to this little segment. And we have 90-degree angles right at the middle. What do I know these diagonals are doing to my opposite angles? Oh, thank you. What is this diagonal, what is DR doing to these two opposite angles? Bisecting them. So MDN is congruent to CDN. MRN is congruent to CRN. And because a rhombus is a special type of parallelogram, angle D, the big angle here, or MDC, is congruent to MRC. So I end up with 4 little congruent angles on opposite sides. Same thing happens to DMR and DCR. These angles are congruent to each other and they are being bisected. All right, they told me that MD was 20, but that was also printed on here. Then they tell me that MC is 24. Where's MC in the picture? It's that diagonal right there. If that whole diagonal is 24, how big is MN? 12. And CN? Also 12, because that diagonal is being bisected. All right, let's find the measurement of angle RNC. RNC. So we're looking at this angle right here. How big is that angle? 90 degrees. And then we have angle DRC. DRC. So this time we're looking for this angle. 18 degrees, that's absolutely correct. They had printed the 118-degree marking in here for us right here. And all 4 of those little angles are the same size. So this one is 18, this one is 18, and the one that we were looking for, DRC, is 18 degrees. All right, angle NMR. N up to N and over to R. So now we're looking for this angle right here. There's a couple ways you could find this one, but I like kind of looking at this little triangle here because I know how big 2 of the angles in that little triangle are. How big are 2 of the angles in there? 18 and 90. So I can do just like I did on part A with the kite, and I can say 90 degrees plus 18 degrees plus the measurement of angle NMR is equal to 180 degrees. What is 90 plus 18? 108. So 108 degrees plus the measurement of angle NMR is equal to 180. And then I subtract 108 from both sides. We get 72 degrees, absolutely correct. All right, so I'm going to write that down on the line, but I'm also going to go add it to my picture. So this angle right up here is 72. Are there any other angles up there that are 72 degrees? Yep. DMN is 72 degrees. DCN is 72 degrees. And RCN is 72 degrees. All right. They want me to find DCR. DCR. So we're looking for this whole angle right here. How do I find that whole angle? Add them up. What am I adding? 72 plus 72. And that gives me 144. All right, 2 segments and then we're done. We need to find segment DN. DN is this segment right here. So now I'm looking at a whole nother triangle, but still a right triangle. I'm looking over here because I'm looking for a side now on a right triangle. And what can I use to help me figure out sides of right triangles? What finds sides of right triangles? Pythagorean theorem. So a squared plus b squared equals c squared. This 20 that's on the outside, does that go in for A, B, or C? C. It is opposite the right angle. So this is my hypotenuse. So I put 20 in the place of C, so I have 20 squared. How big is one of the other sides? 12. You can put that in for A or B, it doesn't matter. But we take that 12 and we square it. The side that we're looking for, DN, goes in for the other one, either A or B. All right, so now we're going to solve this. DN squared plus 144 equals 400. And then I'm going to subtract 144 from both sides. What is 400 minus 144? 256. Then we have to get rid of the squared on the DN. So we square root both sides. On the left, the squared and the square root cancel each other out. So I just have DN over there. And what is the square root of 256? 16. So DN is 16. One last piece that we need to find. They want me to find DR, which is this whole diagonal in here. Well, if DN is 16, how big is RN? RN would also be 16, yes. That's okay. I broke it into pieces. You guys are absolutely right. DR is equal to DN plus RN. Those are both 16. And so that would give us 32. You guys were absolutely correct. Oops. All right, so there's number 6. Number 5 was asked for, and number 13 was asked for. Let's go do number 5 since we're like right there, and then we'll go look at number 13. Number 5, we need to find YAB, the measure of angle I, and the length of GJ. What kind of a shape are we looking at here? What'd you say? Not necessarily. A parallelogram. They tell me right here it's a parallelogram. Parallelograms have opposite congruent sides. So GJ and HI are congruent and they are parallel. GH and JI are opposite sides. So they are congruent and parallel. And because it's a parallelogram, my opposite angles are congruent. So angle J is congruent to angle H, and angle I is congruent to angle G. Which piece do you want to find first? Y, A, or B? Y, sounds good. Y is part of GH, HI, and JI. Yep, we're going to use GH and JI. What do we know about GH and HI? Or sorry, not GH and HI, GH and JI. Yes, those segments are congruent, so their measurements are equal. So GH is 2y plus 2. JI is 3y minus 9. So I substitute that in, and then we solve this for y. First thing I do is get the y's to the same side. So I'm going to subtract 2y from both sides. That gives me 2 equals 3y minus 2y is 1y. So 2 equals y minus 9. Then we add 9 to both sides. Thank you. So y is 11. All right, which one do you want to find next, A or B? A, sounds good. A only shows up in this angle right here. And I have to find a relationship between this angle and one of the other angles in this parallelogram. What's a relationship that I could use to find A? A only shows up right here as part of angle I. And I have to find a relationship between angle I and one of the other 3 angles here that would let me solve for A.
You can add 4A minus 21 plus B plus, no. Are you solving for A or B?
We're solving for A. We can use angle J. What do we know about angles I and J? These are consecutive angles. And what's the relationship of consecutive angles in a parallelogram? 180. They are supplementary, yes. So the measurement of angle I plus the measurement of angle J is equal to 180 degrees. Angle I is 4A minus 21. And angle J is 81. So then I combine my 2 like terms together. I have a negative 21 and a positive 81. When I combine those, it gives me a positive 60. So 4A plus 60 equals 180. Then we subtract 60 from both sides. And I get 4A equals 120. Then I divide both sides by 4. And A is what? Not 3. 30. If you said 30 and I heard 3, I apologize. A is 30. What do you mean? So I do B plus 78 plus 81 equals 180? No. What's the relationship between these 2 angles? If they are equal. Opposite angles in a parallelogram are congruent. So angle H is congruent to angle J. That means the measurement of angle H is equal to the measurement of angle J. So B plus 78 is equal to 81. To get B all alone, I'm going to subtract 78 from both sides. And that gives me B is 3.
You can do the same way I was saying.
You can't add them and set them equal to 180. Not the 81, not angle J and angle H.
I don't know how I got it right, but I got it right. Oh,
That'd be 159. Yeah, if you added those and set them equal to 180, that does not give you the right answer. So if you got the right answer, maybe you did angle H and angle I, because angle H and angle I add up to 180.
Yeah.
That one you could add and set equal to 180. That would work. But then you would need to use your answer from A and plug it in, and you could figure it out that way.
That's probably what I did.
Yeah, and that absolutely works. All right, we need to find angle I. The measurement of angle I, what was the expression we were given for that? 4A minus 21. And we figured out that A was how big? So 4 times 30 minus 21. 4 times 30 is 120. And 120 minus 21 gives me what? 99. So the measurement of angle I is 99 degrees. GJ. They don't have any expressions over there for GJ, so how am I going to find that one? Plug in Y into what? Y plus 4, because GJ is congruent to HI. So the measurement of segment GJ is equal to the measurement of segment HI, and HI is Y plus 4, and we figured out that Y was how big? So I do 11 plus 4, and that gives me what? 15. So GJ is 15. All right, we're going to number 13 next, and then I will open it up for questions again. Number 13 is all the ways we have to see if a quadrilateral is a parallelogram. So one of the ways that we can check to see if it's a parallelogram is, does it meet the definition? The definition of a parallelogram is both pairs of opposite sides are parallel. And then we're going to illustrate that on the picture. So the top would be parallel to the bottom, and the left would be parallel to the right. That's one way to check and see if you have a parallelogram. Does it meet the definition? And then we had 4 other tests to see if something was a parallelogram. One of those tests was if both pairs of opposite sides are congruent, then it has to be a parallelogram. So if I have that the top is congruent to the bottom and the left is congruent to the right, then it is a parallelogram. If both pairs of opposite angles are congruent, then it's a parallelogram. So if the upper left is congruent to the lower right, and the lower left is congruent to the upper right, if my opposite angles are congruent, both pairs, then it's a parallelogram. The third way that we can tell if something is a parallelogram is if the diagonals bisect each other. So I have to draw in my diagonals in the picture. Lower left connects to upper right. Upper left connects to lower right. And I would have to know that they are bisecting each other, so I would have to see some congruence marks. And then the very last way that I could know if a shape, if a quadrilateral is a parallelogram, if I have one pair of opposite sides that is both congruent and parallel, then it's a parallelogram. So if I know that the top is congruent to the bottom, and I know the top is parallel to the bottom, then it's a parallelogram. Or I could know the same thing about the left and the right if I know the left is parallel to the right and that the left is congruent to the right. But it has to be the same pair of sides that is both congruent and parallel. What else would you guys like to see? We got 15 minutes until the bell ending sea lunch. Number 11, absolutely. Number 11, what kind of a shape do I have? A rectangle. A rectangle meets all of the criteria for a parallelogram. So opposite sides are congruent and parallel. So AB is congruent to CD and is parallel to it. BC is parallel and congruent to AD. Rectangles have 4 right angles in their corners. And the diagonals of a rectangle are congruent to each other, but because it's a parallelogram, they're also bisecting each other. So BE is the same size as DE, is the same size as AE, is the same size as CE. All 4 of those little half diagonals are congruent. E right here is my shared midpoint. Yep, they tell us right here that BC is 12 and AB is 8. And then they also tell me that the measurement of angle BEA is 48 degrees. So BEA, this angle right here. No, you're fine. CED would also be 48 because that's a vertical angle, so we could go ahead and add that. Is there anything else that we can add to the picture because of what they told us? Yes, AD is 12 and CD is 8 because those opposite sides are congruent. All right, let's see if we can answer any of their questions about these different sides and angles. We're supposed to find the measurement of angle ABD first. Well, here, oh, sorry, I didn't take it all the way. ABD. Thank you. So we're looking for this angle right here. I heard a really good idea. I know that this triangle right here is what type of triangle? Is that a right triangle? No. It's isosceles. We know that this side is congruent to this side. So this is an isosceles triangle, which means I have two congruent angles. This is one of my congruent angles, so I'm going to call it X. The other angle that it's congruent to is this other angle right down here. That's the other base angle. So I'm going to call them both X. So I would have X plus 48 degrees equals what? Equals 180. I'm going to combine my x's together at the same time that I subtract 48 degrees from both sides. So when I combine my x's, x plus x gives me 2x. 180 minus 48 is 132 degrees. And then we cut that in half. We divide both sides by 2. What is 132 divided by 2? 66. So if x is 66 degrees, then the measure of angle ABD is 66 degrees. All right, so I'm going to add that right here. I'm going to come over here and add it to my picture too. So I'm going to get rid of my shading. These two angles here are 66 degrees. Are there any other angles up here that would also be 66 degrees? BDC, this angle right here, would be 66 degrees. Any others? This little guy up here. Be careful, don't call him angle C, because there's 3 angles there. But ACD is 66 degrees, yes.
Also, you saw another question over there. You saw D.
We did part D. The measurement of angle BDC. BDC, that's this angle right here. That is 66 degrees. All right, what about AED? See, AED. So we are looking for this angle right here. How could I find that one?
Subtract 90 minus 66, then add 24 plus 24, and subtract it 180.
That will absolutely find it. Yes, you can do it like that. So what Jesus is saying is that we could do 90 minus 66 to get this angle right here. That would be congruent to this little angle over here. Then I can add them together and minus it from 180. I see a faster way of arriving at the exact same answer. Does anybody see it? Look at these two right here. What kind of special angle pair is that? Yep, that not vertical. It's a linear pair, and a linear pair always adds to 180. So we can take 48 degrees plus the measure of angle AED is equal to 180. And Jesus, your way of describing this absolutely would work. You would get the exact same answer doing it the way you suggested. We get the measure of angle AED is 132 degrees. What about EAD? That would be this angle right down here. Tell me how you got there.
We already, because I subtracted 132, 180 minus 132 and then divided my answer by 2.
Yep. So we can do that the same way we found ABD. That would work. Can anybody see another way to get the same answer? 90 minus 66. Looking at this angle right here, I know that corner of the rectangle is 90 degrees because we have 4 right angles. So 66 plus the measurement of angle EAD is equal to 90 degrees. And then we subtract 66 from both sides. And the measurement of angle EAD is 24 degrees.
We also solve for
Give me just a second, let me get caught up. So 24 degrees, I'm going to add this to my picture. So this little angle down here is 24 degrees. What other angles would be 24 degrees? Yep, right here, ADE. Up here, CBE. And BCE. Those are all 24-degree angles because the corners have to add up to 90. 66 plus 24 adds up to 90. All right, part E, the measurement of angle DCB. They're asking about this whole angle right here, 90 degrees. And then BCE, 24. BCE is this angle right here. That is 24 degrees. Two more things left to find on this problem. We need segment BD. Well, BD is this entire diagonal right here. So that makes me want to look at this. Got to use what? PT, Pythagorean theorem. If I look at half of this rectangle cut diagonally like this, that makes a right triangle. And do I know how big two of the sides of that right triangle are? 8 and 12. A squared plus B squared equals C squared. The part that we're looking for, BD, should that go in for A, B, or C? It does matter. C. BD is my hypotenuse. It is opposite the right angle. The 8 and the 12 doesn't matter where you put them. But my hypotenuse does matter. So I have 8 squared plus 12 squared. 8 squared is 64. 12 squared is 144. Oh, hold on, let me catch up to you. That would be 208 is BD squared. Then we square root both sides to get rid of the squared. So the squared and the square root cancel. And you said you got 14 point what? 422 is equal to BD. So there's my diagonal BD. 14.422. How can I find segment AE, this part right here? Yes, absolutely correct. So AC is equal to BD. We know BD is 14.422, and AC is 2 times segment AE. So then we divide both sides by 2, and segment AE is 7.211. Very, very nice work. I am recording all of my geometry classes today, so if you had a question about one that we did not go over, I can either answer your question during the D lunchtime. I'm more than happy to do that. Or you can check out the videos from the other classes as soon as they get posted. I will be posting some of those here in just a moment. I also want to show you where you can find the answer key for this entire review, which is already up. So you would go to our Canvas homepage. When you're on our Canvas homepage, you're going to click where it says modules, and then you want to scroll until you see today's date, Tuesday, March 5th. You have to click on the page underneath that says Review for Module 7 Test Day 2. And after you click on that, you will have to scroll all the way to the very, very bottom. Module 7 Test Review Solutions is at the bottom of that page.